Hello students, today I am going to cover up memory management and its requirement. What is memory? The first question arises this one. So firstly we will discuss memory overview, then after we will cover up the requirements. So firstly I am covering up the memory. Memory basically it is an array in terms of bits that stores the information. Memory is of two types as we have heard. It may be the physical memory, it may be the logical memory. Further classification may incorporate volatile and non-volatile memory. In this video lecture, we will generally discuss about the volatile memory. So, memory is a central to the operation of modern computer system. Memory is a large array of words or bytes, each of which has its own address. The program resides on the disk is known as the binary executable files. The program must bring up into the memory, that means primary memory or the main memory, or we can say RAM, place within the processor for execution depending on the memory management system that is in used by the process. So continuously there is a switchover from primary memory to the secondary memory. Secondary memory means hard disk. So, as we have discussed in the previous lecture, that was the process. So, long-term scheduler is responsible to bring up the program from secondary memory into the primary memory. In primary memory, basically has minimum two parts. The first part is for the operating system and second part for the processes. So, if we can say this is the our memory. So this part is allocated to the operating system and the rest for the processes. In the multi-programming system, there may be more than one processes reside in the memory simultaneously. In the olden days, there was only one program can reside in the memory at a time. So the program will be swept in from the secondary memory to the primary memory. Here, when the programs is bring up into the primary memory that is known as the RAM from the secondary memory that is known as the hard disk is known as the swap-in process. And once the program get executed and get completed, it must be swap out from the primary memory to the secondary memory. For example, when I have opened a new file of Word and writing something on it and want to close it. It asks me, do you want to save the content? If I will say yes, so the content will be flushed from the primary memory to the secondary memory. That is flushed out data from RAM to the hard disk. Now, memory management requirement. There are five basic requirement of memory management. First one is the relocation. Second one is the sharing. Third one is the protection. Fourth one is the logical organization. And last one is the physical organization. So we will deal with one by one. So firstly, relocation. Memory is generally shared among several processes in the multi-programming system. So it is not possible to know in advance at which other program will reside in the main memory at the time of the execution of this program. Initially, we cannot separate the memory space for every process. So this is the memory as I have discussed in the previous slide. So this is the memory and this is the operating system. Now, program may reside at any memory location that is available. Swapping the active process in and out of the main memory enables the operating system has large pool of ready to execute program. Means this memory contains a set of programs that are ready to execute by the processor. If this is the processor, so if there are 10 programs, that means they are ready to execute and they are placed in the ready queue. Whenever they have the turn, they will be allocated to the processor. When a program gets swept out from the disk memory, then it is not uh, always possible that when it is swept back into the main memory, then it will occupy the same previous location. Suppose that at present I am watching a movie. I want to watch a movie, so I will bring up the movie file from secondary memory to the primary memory. Suppose that movie reside at this location. I have I have seen the one by two of movie. Due to some work, I have left out the movie in between and closed it. And then after certain time of interval, I have restarted from want to see the movie. So I will bring up from secondary memory to the primary memory once again. So this is not possible. The program will reside or the movie will come back into the same memory location, because this may be possible. Some other program may be residing on this location, or this may be possible. This memory location is still empty, so my movie will reside on this location. So there is no need or there is no fixed location of the particular program that will occupy in the RAM, or we can say primary memory. So relocation is there from one location to another location when it will bring up into the memory or primary memory or RAM again and again. There is no specified location where the program will come. Second one is the protection. Protection is one of the important characteristics of memory management requirement. Suppose that we have specified or we have fixed the memory partitions. This is OS. Program P1 is residing here. Program P2 is residing here. And this is the empty place. So the address generated by the CPU is known as the logical address. This is the CPU processor. It will generate an address for a particular instruction. So that is the basically logical address. This logical address is converted into the physical address to get the memory access. How this will be, we will discuss little bit later in the next video. So the logical address will be converted into the physical address. Physical address provides the actual memory location where the instruction reside. So this for program P1, all or process P1, all program will reside only at this location. So P2 cannot access the memory location of P1 because it is a definite location and reserved for only for the process P1. Similarly, P2 cannot interfere, cannot access the memory location of P2 until there is some shared location accessible. So we must provide the protection means fence so that P1 cannot enter into the P2's location and P2 cannot enter into the P1 location. So how this is possible? This is possible with the help of the two registers. First one is known as the base register and second one is known as the limit register. So firstly we will discuss base and limit register. Then after we will discuss in the detail rest of the requirement. So CPU generate an address. This is known as the logical address. Suppose that it generates an address for the program P1. Firstly, in the logical address, that is generated by the CPU will be checked by the base address. Here I am not discussing how to convert the logical address into the physical address. At present, I am not dealing with that. That will be the part of the paging or the segmentation. I am not covering here. I am just giving an example. CPU generates an address that is a logical address. It will check whether the address generated by the process P1 that is start from the base address. Basically, a base address is a base register is a register that contains the starting value of that particular process. Suppose that it is 2000. Actually, it is in the hexadecimal, but here I am taking as a decimal. So process P1 start from the memory location 2000. So this contains the base register. And second register is known as the limit register. Limit register, this one. Limit register defines the limit of the process. Suppose that it is 500. So in that case, it will occupy maximum 500 bytes, means it will end at the 2500 address. So this will be the limit register, that is your 500. So firstly, it will check whether the process that have a address equal to the base register or not. So here base register value will be checked. If it is, then it's okay. If not, then it will be get terminated, because maybe possible this is the process P1, maybe possible P2 process is residing here, and it may generate an address 1599. So this is the address of the process P2, not of P1. So it will get trapped. If yes, then it will move here. Now it will check whether the address generated by the CPU will reside in this limit value or not. Suppose that the CPU has generated an address 2800, means 2000 is the base value and 800 is the limit register. So it will generate another address that reside in the basically location of process P3. So this should not be there. That means the address generated by the CPU must reside between the 2000 to 200, 2500. That means 2000 to 2500. So it will check the value. If it is lesser, then it will search for the address, otherwise trap. Suppose that it has generated the address 2399. So it reside in the vicinity or in the belongs to the location of process P1, that is between the 2500 2000 to 2500. So it can be accessible. So here the example is the base register has the value this one, and the limit register has the value this one. So this process, let it is P1, the base register value will be added to the limit register, and the limits fans of the process P1 can be defined. Similarly for the process P2, similarly for the process P3, the limit can be defined. So by this way we can protect the memory. Next, coming on the sharing. Sharing, basically when we are dealing with the multiprocessor system, or in the process synchronization, then there must be sharing of memory. A protection mechanism must be allowed several processes to access the some portion of the main memory, allowing each process access to same copy of the program rather than have their own separate copy as an advantage. For example, suppose that I have opened a word editor So word editor has the editor data, ed1, editor file, and then after editor data, ed data. So when a program brings up into the main memory, that means MS Word or the editor, so editor itself have to occupy some space in the memory location it resides. Then after, if I am typing something and I have created a 10,000 word file, that will also store in the memory location, that means primary memory, until we will not save it. So it is residing. So the space occupied by the process is this one, that is the editor file space, and second one is the data space. Now suppose that I want to open another file. So in that case, or we want to create another file, in that case only the data space will be allocated to another process, not the editor space, because editor is already in the memory. Why we should bring up the editor once again? If we will brings up the editor copy once again, so there will be redundancy, it will occupy the double space, so it will create the problem. And along with that, it will take or occupy more memory, so there is a wastage of memory. So we will not bring up the editor files once again, or brings up the editor once again. Only the data file will be created or bring up from the secondary memory to the primary memory. So this is discussed here. Multiple processes may use the same file. It is natural to load one copy of the file in the main memory and let it be shared by those processes. It is the task of the main memory management allow control access to shared area of memory with the without compromising the protection. Next one is the logical organization. The processes are composed of modules of varying size, modules independently compiled, modules with different protection needs, even the degree of sharing, how many portion we have to share. Some of the program may be unmodifiable, that means read only, and or some are the execute only, and some of those contain the data that can be modified. So how to organize those data may be possible when it is bring up into the main memory. They will not occupy the same space, or we can say entire contiguous memory location. This may be possible. Module may reside here, data may reside here, and so on. So how to organize the data logically? This is one of the critical issues that should be handled. Last one is the physical organization. The structure of the computer memory has two levels referred as the main memory and secondary memory. Main memory is reflected relatively very fast, costlier as compared to secondary memory. Main memory is volatile and secondary memory provides the storage for the data on a long-term basis, while main memory holds the current data that is currently in use. So how to store a file in the secondary memory? So there are number of techniques here. We are using basically three techniques that will be covered up in our curriculum. That is the indexed allocation, indexed allocation technique, index. Second one is the linked allocation technique, and third and last one is the continuous allocation. Continuous. Windows is using the linked allocation. Suppose that in the linked allocation, the entire file or entire data is scattered throughout the disk. So for accessing the data, the HDD's head has to move from one track to another track continuously to read the data. So by this way, it is moving, the arm is moving to read the data. So we can defragment it. In case of defragmentation, we will organize the scattered data into the contiguous memory location so that accessing of the data will be much faster. Nowadays, we are using the SSD drives. So SSD drives are much faster because these are the electronic secondary storage media, while HDD hard disk is a electromagnetic media. So where the mechanical works involves, it takes certain amount of time to access the data, to fetch the data, to read the data, to write the data. So it will take time. So how the data is organized on the secondary media or the physical device is also responsibility of the memory management module. So this is the swapping that we have discussed to bring up the data from primary memory to from secondary memory, that is known as the baking store, to the primary memory. That process is known as the swapping. And once the process data has been get executed, it should be swapped out from primary memory to the secondary memory. Now, as I have discussed already, CPU generates an address that is known as the logical address, while an address seen by the memory unit is commonly referred as the physical address. So we have to convert the logical address into the physical address. So we will refer two schemes. First one is the paging and second one is the segmentation in our future video. The execution time address binding scheme results an environment where the logical and physical address are differ. In this case, we usually refer the logical address as a virtual address. So logical address is also termed as the virtual address. For example, CPU has generated an address that is 346 and the memory relocation register has the value 14,000. For example, up to here, that is 14,000, the OS reside. Here, this memory location OS reside. So we have to add 14,000 in the address generated by the CPU. So this will be 14,346. So this address is known as the physical address, while the address generated by the CPU is known as the logical address. This is the responsibility of the memory management unit, how to convert the logical address into the physical address. This is all about the basic concept of the memory management from my side. Thank you.